Yesterday we reviewed all of our exponent laws, and today we're just going to expand on that and look at what happens now if our exponent has a fraction in it. But before we can do that, we just need to review a little bit of our basic math terminology. For example, the square root. The square root of x is a number which, if it's squared, will equal x. So for example, the square root of 49 is equal to 7 because 7 squared equals 49. So that's just sort of the opposite. So a square root just means that a number multiplied by itself is equal to the number under the square root sign. So a cubed root is very similar. A cubed root, now we show the 3 because otherwise it's assumed that it's a square root. So the cubed root of a number, cubed root of x, is a number which, if cubed, will equal x. So for example, if we're looking for the cubed root of 8, that is equal to 2 because 2 cubed is equal to 8. Remember that being multiplication. 2 times 2 times 2 is equal to the number under the square root sign. We're looking for a number multiplied by itself 3 times. This works the exact same for the fourth root. So now we have a 4 by the root, showing that that's fourth root. So if we look at 81 there, the fourth root of 81 is equal to 3 because 3 to the power of 4 is equal to 81. 3 times 3 times 3 times 3 is equal to what's under the square root sign. So you're looking for something multiplied by itself 4 times. So in general, this works for all n roots. That's what we're saying there. No matter what it is to the power of n, you can take that as a root. So we'll just clean that up. Please note that it's not possible to take the square root or the fourth root of anything with a negative under it. So here I cannot find the square root of negative 8. There's no two numbers multiplied by themselves that will ever give me a negative number. That's the same for all even exponents. But it does work for a cubed root, as we've shown here. The cubed root of negative 8 will work because negative 2 times negative 2 times negative 2 will give us a negative answer. But even exponents will not. So we can never have an even root, square root, fourth root, sixth root, etc. All right, so let's look at a few examples to help make some sense of this again. So the cubed root of 27 is 3, and that's because 3 multiplied by itself 3 times is 27. The fourth root of 16 is equal to 2, because 2 times 2 times 2 times 2 is equal to 16. 2 times itself, 4 times, repeated multiplication. Negative 5 is the cubed root of 125, and positive 2 is the fifth root of 32. Take some time right now and have a look at your calculator and be sure that you can find your exponent button on your calculator. Your exponent button will look like this, or like this on your calculator. All three of those buttons will do the same thing. So if you wanted to check your work here, if you hit 2 on your calculator and then your exponent button, a lot of them look like that arrowhead, 2 to the power of 5, and that hit equals, you should get 32. If you're having any problems with your calculator, just be sure to bring it into class tomorrow and we'll practice with it. All right, so what we're going to look at now is we have a base of x to the power of 1 over n is an alternate notation for n root of x. So we'll make some sense over this in a second, but here we have 25, the square root of 25 to the power of 2. And those will cancel out to be 1. That's what this is saying here. So if I had the square root of 25 squared, square root of 25 is 5 squared is 25. So you can see how those take you back to the same thing. So the square root and the squared sign actually just cancel out. So here we know power to our calculator that 25 to the power of 1/2 times 2, power to a power says to multiply. What I'm left with there is 25, 2 over 2, which equals 1. So we're just showing you how all of these exponents, so to speak, cancel each other out. Same thing with cubed roots. A cube root to the power of 3, they cancel out to become 1. And 8 to the power of 1/3, you have to multiply that by 3, and that becomes 1 as well. So what we realize is the denominator of our exponent becomes our root. So for just a minute, just trust me, try with your calculator so you can see yourself. If you took 25 to the power of 1/2, use your calculator, 25, hit your exponent button, to the power of 0.5, you're going to see that that equals 5. The same thing as square rooting it. So if you did 49 to the power of 1/2 on your calculator, you should be seeing 7 on the screen. So anything to the power of 1/2 is the same thing as writing the square root of it. Different ways of writing the same thing. So if we had 8 to the power of 1/3, and you can try this with your calculator. This is just another way of writing cubed root to the 1/3. So my answer there would be 2. All right, now if we look at some of our examples here, the 8 to the 1/3, that exponent, we just did that example there. So 8 to the power of 1/3 is the same thing as writing cubed root of 8, which we then ask ourselves, what's the number multiplied by itself 3 times that equals 8? And that's 2. 2 times 2 times 2. The cubed root of 64, so another way of writing 6 to the 1/3, cube root of 64 would be 4. 4 times 4 times 4 equals 64. The fourth root of 81 would be 3. And you will get to know these as you do your homework and you practice. You're going to start to become a little bit faster. At first, you might have a little bit of guessing that goes with it. Now be careful here when we look at this exponent here. What that is saying is 16 to the negative 1/4. I'm going to clean this work up just to give us a little bit of space so we don't get confused. Now, whenever I have a negative exponent, I need to first take the reciprocal of the base and make my exponent positive. So what that is, that's the fourth root of that whole fraction. Now I know any number multiplied by itself 4 times, 3 times, the fourth root of 1, the square root of 1, the cube root of 1, no matter what, is going to be equal to 1. Now I'm trying to ask myself a number multiplied by itself 4 times that equals 16. And that would be 2. 2 to the power of 4 equals 16. So 16 to the negative 1/4 is actually equal to 1/2. So our last example here of 9/16 to the negative 1/2, I take the reciprocal, and that makes my exponent positive. So the whole fraction is to be square rooted. The square root of 16 and the square root of 9, which leaves me with 4/3. Okay, our concept doesn't change much more as we do our last 3 examples, but the only thing we need to realize, and that's what's typed there, is what happens if the numerator isn't 1. So far that has been all of our examples. So we can see in general here, let's draw our attention here. Sorry, there we go. This is what you're going to need to realize, that when you have a fraction of m over n, that your numerator still, like the examples above, the numerator still tells you what your root is, but the denominator still tells you what the root is, like the examples above, and the numerator is now the exponent. Let me just show you here with this 8 to 2/3. Let's just elaborate on this example here. So if I had 8 to 2/3, I could also write this as 8 to the power of 2, power to a power, and the 1/3. Because you know that when you multiply fractions, 2 times 1 is 2, all over 3. So I'm just separating it. So it's mathematically sound. And now this looks like the examples we did above, where the numerator is 1. So the denominator tells me the root, just like we did above. Denominator tells me the root. The 8 is under, and my exponent is the 2. And I like to do it this way. I do the root first so that my numbers get smaller rather than larger. If you started with the exponent, if I did 8 squared, I would have 64, which is a bigger number. The cubed root of 64 would still get me to 4. So my answer is going to be the same, but I find it easier to do the root first again, so we're working with smaller numbers. So let's look at 16. To the 3 over 2. My denominator is my root, so that's going to be squared. That comes under the root sign, and then my exponent. I like to do the root first, so to square root 16 is 4, and then worry about my exponent, and that would equal 64. Last example for today, 25 over 4 to the negative 5/2. The first thing I do is I take the reciprocal of the base so that I can make that exponent positive. I don't take the exponent, I don't take the reciprocal of the exponent. It stays the same, it just becomes positive. The denominator is the root, so I'm going to square root 4/25 and then make it all to the power of 5. So I have 2/5 to the power of 5. So you can simplify it like that. If it asks you to evaluate like this question does, then you actually want to put that in your calculator, 2 to the power of 5, and then 5 to the power of 5. What you want to be sure that you note here at the bottom, this is very, very important. These are all of the exponents we expect you to know, because you're going to practice them enough and that you can do without your calculator. So you should be able to do 2 to the power of 10, 3 to the power of 3, 4, and 5, 4 to the power of 3, 4, and 5, etc. So you can take note of that there. Anything without a calculator, we can assume that you could do that as mental math. So we have practice questions here at the bottom that will be assigned tomorrow in class, and we'll take up any questions then.